This video is about complex numbers. We're gonna, or imaginary numbers. This is what they're referred to. The name imaginary kind of is not the best name because it makes students feel like that math teachers are just messing with them. They're just making up pretend things for them to torture them, but that's not the truth. Imaginary numbers are simply a way of defining a different category of numbers, a different dimension of numbers is what it is. And so this is the imaginary number I, and it's defined to be the square root of -1. So complex numbers are numbers that have this little I in them, and they are the category of numbers that are negatives under square root. So previously, when you came across the square root of a negative, you would say not a real number, and that's true. But now we can talk about it. It is, in fact, a complex number. So let's just look at this. What if I had the square root of -7 or the square root of -121? Let's just look at these. Previously, we would just say these are not real numbers, and they are not. But what you want to do is think of this as the square root of -1 times 7. And when you take the square root of -1, it pulls out as an I times the square root of 7. And this is how you can simplify a number like that. This right here, this would be I times the square root of 121, or known as 11 times I. So that's how you can simplify some complex numbers. Complex numbers are simply this. You have A plus B times I, where A and B are real numbers. A is known as the real part, and BI is known as the imaginary part. So for instance, if I have a number like 11i, what is its real part? Well, its real part is 0. If I wanted to write it in the complex number form, that would be 0 plus 11i. What if I have a purely real number, which in fact is what we have dealt with almost our entire math life? What if we have the number 5, which we're familiar with? We like 5. There he is. He's a real number, but he's also part of a complex number. 5 plus 0i. This is the truth about the number 5, is the imaginary part to him is 0. So this is how we would write a purely real number, a purely imaginary number. They are subsets of complex numbers. So then sometimes we could have 3 minus 2i. We would say the real part of this is 3. The imaginary part of this is -2i, complex numbers. Okay, so what you can do with complex numbers is you can add, subtract, multiply, and divide them. So here we go. Let's add, subtract, multiply, and divide complex numbers. Goes like this. It's pretty straightforward. Once you get your head wrapped around the fact that you accept the fact that an imaginary number is not pretend. And so how I try to emphasize this in students' minds is this is the truth. Most of the applications for imaginary numbers have to do with electrical current. So if you get shocked, you can get shocked by electrical current, and you can get shocked by the imaginary component of electrical current just as real as you get shocked by the real component. So it is just a way of describing another dimension of numbers. Okay, so here we go. Let us learn to add, subtract, multiply, and divide complex numbers. To add and subtract complex numbers. If we have got A plus BI plus C plus DI, if we're going to add these two numbers, you simply add the real parts together and the imaginary parts together. So this would be A plus C plus I times B plus D. If it was subtraction, then if this had turned into a subtraction, let's say, what would we get then? Then that would be, you would distribute the negative. So it would be minus C minus DI, basically. So then this would be A minus C plus I times B minus D. And this actually looks a little more complicated than it is when we have real numbers in there. You sort of just treat that I as a variable almost. So Let's just add some of these guys together. What if we've got 2 minus 4i minus 6 minus 8i, or we have something like 7 plus 5i plus 2 minus 9i. Let's just add these complex numbers together. Distribute the negative, minus 6 plus 8i. Add the real parts together, 2 plus negative 6 is negative 4. Add the imaginary parts together, negative 4 plus 8 is a positive 4i. That would be the subtraction of those two numbers. Let's add these two. If there's a positive 1 in front of a set of parentheses, you don't really need them. So I'm going to remove those because I know that it won't affect anything. I didn't do that when there was a negative. I had to distribute the negative to both terms. So if it's a positive one, it's fine. Add the real part. 7 plus 2 is 9. 5 plus negative 9 is negative 4i. That's how you would add those together. Now we're going to multiply. Okay, for multiplication, this is the big deal. I is equal to the square root of negative 1. I squared is equal to I times I, which will be the square root of negative 1 times the square root of negative 1, which is the square root of negative 1 squared. And what happens here is the square root symbol and the squared cancel each other out. So this is really the big deal. I squared is equal to the real number negative 1. I squared is equal to negative 1. This is the big news. So we're going to be using that when we multiply. So let's multiply some together. Multiply. What if we're multiplying this, let's say? Let's see. What if we've got 3 plus I times 2i? And then what if we've got 2 minus 4i times 2 minus I? Okay, let's do these first. This term will distribute to this term. So 3 times 2 is 6i. And 2i times I is plus 2i squared. However, I squared is really negative 1, and you never leave it sitting like that. So it's 6i plus 2 times a negative 1, which would be 6i minus 2. And if you want to rearrange the terms, you can call this negative 2 plus 6i, the real part and the imaginary part. Let's go again down here. We have basically a binomial times a binomial. So 2 times 2 would give me 4. 2 times negative I would give me minus 2i. And then negative 4i times 2 would give me negative 8i. And then a negative times a negative gives me a positive. 4i times I gives me 4i squared. All right. We can collect these imaginary parts together. Negative 2i plus negative 8i is negative 10i. Right here, I squared is really the number negative 1. So this is really 4 times negative 1. This is really a negative 4. Well, 4 plus negative 4 is 0. So really, this whole thing multiplied together becomes negative 10i. So that's multiplication. Now, here is something important, and we saw this before with radicals. Complex numbers and radicals sort of go hand in hand in so many ways. We can talk about division of complex numbers. And so division of complex numbers basically means get rid of the imaginary part in the denominator, same as radical numbers. Division of radical numbers means get rid of the square root or cube root in the denominator. So if we're given, if they say divide, let's divide these things. And they say, first let's say they give us something like this. 16 plus 15i over 3i. Let's do that one. Or they say 2 over 3 plus I. Or they say 5 over 2i. Or they say negative 11 over 8 minus 4i. Okay, these kind of go in two categories. One category is division by a pure imaginary number. See, this one fits in that category, and that one fits in that category. The second one is division by two terms. It has a real part and an imaginary part. It has a real part and an imaginary part. The job for division in all of these cases is to get rid of the I in the denominator. So this is how we do that. We take two different approaches. One is when we are given pure imaginary number in the denominator. Let's look at that one first. This will always fix the situation. If you take that and you multiply by I over I, which is called a well-chosen one. If we multiply by I over I, it fixes that. It's also legal because we're multiplying by the number 1. If we choose to multiply this by I over I, that will fix this situation, and also this one, I over I. So let's start right here with this one. Multiplying fractions, multiply the numerators, multiply the denominators. This is 5 times I over 2 times I squared. But I squared is really the number -1. So this is really 5 times I over 2 times -1, or 5I over -2, or simply -5/2 I. The job was to get rid of the I in the denominator. We did. Do you see how I wrote that I beside it? When a variable or I is written beside a fraction, it goes in the numerator, or it could also be written in the numerator. That's how that's understood. All right, let's take care of this one. Since there's two terms in the numerator, it will distribute to both. So this goes like this: 16I plus 15I squared over 3I squared. This becomes 16I, remember this is really a -1, minus 15 over, this is really a -1, 3 times -1, -3. We can simplify this. We could call this -15 plus 16I over -3. We could say -3 goes into -15 5 times, and then 16 divided by -3 is 16 over 3I, the real part and the imaginary part. The job was to get rid of the I in the denominator, and we did that here, and we did that there. Okay, that's those two. Now let's tackle what do you do when there's not just an imaginary portion, but there's a real and imaginary portion in the denominator. Well, you've seen this before, and it's very much like division of radicals, where you have to handle it with a conjugate. So just like we had conjugates for radicals, we have complex conjugate for complex numbers. So the conjugate or complex conjugate of A plus BI is A minus BI. So the complex conjugate of -7 plus 4I, 6 minus 2I, minus 4 minus 8I, 2 plus 11I would be keep the real part, change the sign of the imaginary part. Keep the real part, change the sign of the imaginary part. Keep the real part, change the sign of the imaginary part. Keep the real part, change the sign of the imaginary part. Keep, change, change. So these are examples of complex conjugates. How do we apply that in division of complex numbers? Well, we multiply this by 1. That is what's legal, but what we choose to multiply it by is the complex conjugate of the denominator over the complex conjugate of the denominator. It looks like this. We have 2 over 3 plus I. The conjugate, the complex conjugate would be 3 minus I. We're multiplying by 1. That's legal. Let's go ahead and see what happens. We have 2 times 3 in the numerator, which is 6. 2 times -I is minus 2I. Down here, 3 times 3 is 9. 3 times -I is minus 3I. 3 times +I is positive 3I. And I times -I is negative I squared. But we know I squared is really a -1. So this down here turns out to be 9 plus 1, or a 10. We can factor out a 2 from the numerator to simplify this at this point. 2, 3 minus I over 10. 2 goes into 10 5 times. So most simple form, this is 3 over 5 minus I over 5. The job was to get rid of the imaginary part in the denominator, and we did that. Okay? Also, you could write this as 1/5 times I as well. That means the same thing. Let's do this one. There's 2 things in the denominator. I cannot get by with multiplying by I over I. I must go with conjugates. So the complex conjugate here is 8 plus 4I over 8 plus 4I. Now I'm running out of room, so I'm probably going to move this problem up here. When I distribute the 11, I can distribute the negative 11 in the numerator. So let's do that. We would get negative 88 minus 44I in the numerator. Down here, 8 times 8 is 64. Negative 4I times 8 is negative 32I. 4I times 8 is plus 32I. Those will add to 0. They always add to 0 because they're conjugates. Negative 4 times positive 4 is minus 16I squared. Okay, I squared is really a negative 1. Okay, so we have negative 88 minus 44I over 64 plus 16. So 64 plus 16 is going to be 70. I can't hardly think. 80? Is that right? Oh my goodness. 78. This is going to be 80. Okay. I am seeing some 4s. I definitely could factor out. I think does 4 go into 80? Yeah, I believe it does. I think I could divide the top by 4. Let's see. Divided by 4. Divided by 4. How many times does 4 go into 88? 22 times minus 22. How many times does 4 go into 44? 11. How many times does 4 go into 80? I think 15. I'm not sure. 80 divided by 4. Oh, it's 20. That makes sense. I don't know where my brain is. It's 20. Okay, so we could write our answer like this, or we could say this is negative 22 over 20 plus 11I over 20. This could even simplify to negative 11 over 10 plus 11 over 20. But basically the job was to get rid of the imaginary part in the denominator, and we totally did that. Okay, division, addition, subtraction, multiplication, and division of complex numbers.